All right, so air's being pumped into the spherical balloon. You're going to love my picture drawing. Okay, it's totally sweet. So you've got this balloon. Okay, so we're blowing air into this balloon. All right, and it's spherical, which means it's a sphere. Okay, it's a basketball. Okay, sorry, no hockey puck going on yet. We're getting to hockey pucks later. It's going to be a whole hockey section. Okay, so right now it's a sphere. All right, what are some of the things that change in a sphere? Before I even read the problem, let's just understand the context of the problem. What are some of the things that are changing? Obviously the radius, the circumference, the volume, surface area. We don't really ever ask for surface area. We usually don't ask how the surface area is changing. I mean, I'm sure there's problems that are relevant for that. I mean, think about surface tension on the water. I'm sure stuff like that matters, but for what we're doing, I have not really ever done a rate of change for surface area. I'm sure it's been done, but I just haven't done any. We're doing a lot of geometry stuff where it relates to volume and area. Not surface area, but like area of a circle or area of, something expanding. So air is being pumped into a spherical balloon at a rate. So air is going into the balloon at a rate of 4.5 cubic inches per minute. Find the rate of change of the radius when r is equal to 2. So we understand the context of the problem. Let's write down some of the things that we know. Do we know any rates? Do we have any derivatives?
Yes.
Which derivative do we have?
Air pressure.
Let's look at this. 4.5 cubic inches per minute, because you have to have a little bit of common sense here to figure this out, like math common sense. Which one is this related to? I'm blowing air into the balloon. What is that changing?
Volume.
That's volume. And here's the key for volume. That's how you know it's volume. That's the key word right there. Cubic should let you know, oh yeah, this is volume. Okay, it's not radius. Radius would just be inches, not cubic inches. It's not circumference, because that would just be inches. It's not air pressure. It's not anything like that. It's straight up volume, because anytime we're talking about cubic units, we're talking about volume. Square units, we'd be talking about area. Units, we'd just be talking about length. Okay? So understand dimensions and how dimensions work. So if this is volume and blowing air into the balloon, when you put air into the balloon, you're changing the volume. If you put something into a bottle, like a fluid, you're changing the volume, capacity, think of it like that. So D what then? This is a rate, so rate. dV what? No, it's always done with respect to what? Time. So 4.5 cubic inches, write that down. Always write it down like this. Cubic inches per minute. Always write them down. Write down the ones you know. That's the first thing you do after you do your drawing. If you need a drawing. Sometimes you don't need it. And then go on. Find the rate of change for what? So how are we going to write that one? dRdt. And that's the one we're trying to find. So what I do is I always put a question mark. Just remind myself that's the one I'm looking for. So question mark, okay? And then it goes on, it says when the radius, so I'm going to put that, when r is equal to 2 inches, because now that freezes it in time. So when the balloon gets to a radius of 2, that's an instant in time, right? That's a moment in time. So when I get my radius to be 2, that's it. I don't care what time it is, because it's all relative. I just know that represents a moment in time. All right? Now, think about this. We know the radius is changing. We know the volume's changing. There are other variables that's changing, but I don't think that matters so much here, because is there an equation in a sphere that relates the volume to the radius without having to worry about any other variables? Okay, you would never have to know that. In the AP exam, it will be given to you. Much will be given to you, so much will be expected. Okay? The volume for a sphere is 4/3 pi r cubed, which is really awesome. Why is it awesome? Because it only has volume and radius. Okay, which is nice, because those are the two that I know or don't know. And if it's the one I don't know, it's actually the one I want to find. So there's no variable here like in the last problem. We had that dumb y. Because the only equation we could come up with was x squared plus y squared equals r squared. There's no avoiding the y. This one, you don't have that problem. So if we don't have that problem, we've already done step 2. We've wrote our equation. We can go right on to step 3. What's step 3? Find the derivative implicitly, both sides with respect to what? Try it right now on your own. Take the derivative of v equals 4/3 pi r cubed, both sides with respect to time. Do it. It's not even that hard. It actually just uses simple power rule. Let's see, all right. Let's start with the left. Let's get everybody started on the right foot here. V, what's the derivative of V? It's 1V, so what's the derivative? 1 times what? So it's just a dv dt. So the left side is just...
Just put in 4.5 right there.
Not yet. Don't ever plug in until you've taken the derivative. The only time you're allowed to plug in before you take the derivative, everybody listen to me, ears perked up. The only time you're ever allowed to plug in before you take the derivative is if you know what you're plugging in is never going to change. It's constant. It's never going to change. If there's something that's never going to change, but volume, does it change? Radius, does it change? So you can't do any substituting until you've taken the derivative. That's a big rule. That's like a law of iRobot. Okay, remember how they had 2 laws, three, or whatever. This is one of the laws. Okay, don't ever plug in unless it's constant. Okay, number 2. Don't have a variable in there that you're not interested in. And number 3, don't get the problem wrong. All right, here we go. So dv dt, what about the right side of the equation? Yeah, because you're going to multiply by what? Simple power rule. Your variables are, everything else is constant. So 3 times 4/3 is just going to be, the 3's are going to cancel, you end up with 4 pi r squared, but don't forget something, dr dt. That would be rule 3. Remember to multiply things by things implicitly. All right. Are we good? Did that make sense? Not that bad, right? I mean, they do get harder. I'm not going to lie. They do get harder, but you can handle this, right? You understand it? Okay, now, if I'm wanting to find dr dt when r equals 2, and I know dv dt, now I'm at the step where it should just fall right out. It should just be natural. It just flow forth and just say, I'm fourth, okay? The ones I know, let's plug you in. All right. So what do we know? We know dv dt. What's that one? 4.5. You can go home and tell your parents that you solved the related rate problem. They'll be all pumped. Okay. Mom will look at you like, what? Equals 4 pi. Do we know r? Yeah, we know r. The reason you don't want to plug that 2 in the beginning is because the radius was changing. R doesn't always equal 2, so you can't plug it in until you've taken a derivative because you haven't represented it as a changing variable yet. That's why you can't plug in the 2 in the beginning. But some people want to plug the 2 in before they take the derivative. If it's changing, you can never do that. First law of robots. All right, dr dt is the one I'm trying to find. Okay, now, hold on just a second here. I'm going to actually put the units in here. And I put the units in here for a reason. You don't have to, but here's the thing. I'm going to tell you how I keep up with it. I'm going to tell you a couple shortcuts to keep it up with units. If you didn't plug them in, that's fine. All right, so we're going to end up taking 4.5 and dividing it by what? That's 2 squared, which is 4. 4 times 4 is what? 16. So we're going to have 16 pi over here. So we're going to take 4.5 divided by 16 pi, and if you're going to do this on the calculator, the 16 pi has to be in parentheses or it won't divide by the pi. It'll multiply by it. So take your calculator out if you want to make sure everybody gets this. You need a calculator for the whole homework. All decimal stuff. All right, let's round to 3 decimals and then I'll talk about the units. Since I'm approximating, I'm going to use squiggly little equal signs. So what's 4.5 divided by 16 pi? Please make sure your 16 pi is in parentheses. Let's round up at 3 decimal places.
0.09.
So 0.090. Now, let's figure out the units. Let me tell you how you can do this. You can understand the units from the problem, but there's a shortcut. You ready? Okay, now here's why it ends up being what it's going to be. It's going to end up being inches per minute. And let me tell you why. Because if you look at the problem, this is cubic inches per minute. This ends up being what? Inches squared, and you divide it by inches squared, which canceled inches cubed into what? Inches per minute, and time doesn't go away. Now, another way you can understand this is if you understand what the units are for the variables. Time is already measured in minutes. I can look at that from the problem. Volume is always cubic. So once you determine what cubic it is, inches, feet, meters, miles, whatever, then you just know it's cubic units per minute. So if it's inches, it's cubic inches per minute. Radius, height, width, length, those are always one-dimensional. So when you look at it here, dr/dt, you're like, okay, R is measured in inches, time is measured in minutes, so it's just inches per minute. Inches cubed per minute. So you should just be able to look at your derivative notation and just be like, okay, dr/dt, R is inches, time is minute, inches per minute. Okay? That's how you can keep up with the units. The only thing that's square units is when you get into areas. So volume's cubic, areas is squared, everything else is one-dimensional, and it's just units. All right? Feeling good about it? Let's go to a harder one. Keep going. Let's do another Pythagorean theorem one, and then we'll do a really fun one. This one right here, I have a diagram to give you to be able to do it. Okay, so let me do it right now. You've got an airplane. Watch my airplane. It's totally weird. Got a little thing there. I fly Delta, so. Okay, this airplane, and there's Camden, since his dad is a pilot, we'll make Camden the pilot. Okay? It's like a flying banana now. Okay, but anyway. Alright, so we've got this airplane. It's a certain distance away from a radio tower, a radar tower. So we got a radar tower here. Okay, so here's my little radar tower. Okay? It's like an old antenna on a trailer. But anyway, and I grew up in a trailer, so don't make fun of trailers. Right? My first house was a trailer. Me and my wife, we called ourselves Trailer Treasure. Right? My wife, we bought our first house, it was a trailer, and she goes, because you know what they say about people down south in trailers. And anyways, my wife. Well, we North Carolina, West Virginia, trailer trash kind of people. Anyway, so I grew up in a trailer, and we bought a trailer. My first house was a trailer, and my wife's like, we are Trailer Treasure. So she'd go home every day and say, we are Trailer Treasure. And it is so bad because in front of the kitchen sink, the floor was caving in. So I had to like put plywood over it just to keep you from not falling through. Anyways. You don't have as many trailers up here because it's so cold, but down south you see lots of trailers. Okay? Anyways, so we have a distance from the radio tower. We're going to call that distance from the radio tower S. That's the direct distance. Okay, let me talk about an airplane a little bit. The distance above the ground, does anybody know what that's called?
That's delta y.
We call it the height, but what is it actually called? Altitude. Now, I'm going to actually tell you what that height is. It's 6 miles. Now, we're saying delta, this flight is traveling 6 miles above ground, and it's going to stay at that altitude. We're going to stay at that current altitude. And let's read the problem. It says an airplane is flying on a path that will take it directly over the radar tracking station if S is decreasing at a rate of 400 miles per hour when S is equal to 10 was the speed of the plane. Now, there's one more variable I want to give you, and I want to represent the ground distance, which is x. And Cannon would be able to tell you this, but how do they measure the speed of an airplane? Do they measure the speed of it going vertically, horizontally? Do they measure its actual path? How do they measure the speed?
It's air to ground speed.
It's ground speed. So when we're talking about the speed of the plane, we're talking about the speed that it travels if it was like a car traveling on the ground. So how far does that cover that distance across the ground? That's the actual speed of the plane. So an airplane is flying on a flight path that will take it directly over a radar tracking station. Okay? And we're going to stay at 6 miles, no matter what. The plane's going to stay at 6 miles. So what do you know about this variable here? I'm going to make a note of that. That is constant. That's nice. Which means its derivative, which would be what? What's derivative? dH dt would be 0. Very good. Its derivative would be 0. And that's nice. And anytime that happens, I'm going to tell you, because rule 1, I said, don't plug in constants unless they're not changing. Is h ever changing? So you actually can plug this one in before you change the derivative because its derivative is 0. It doesn't ever change. It's always going to be at an altitude of 6 miles. Not always, but until we get to the airport. Okay? All right. For this problem, it's going to always be 6.
So it's just x squared equals s squared
No,
though?
not yet. Okay? So an airplane is traveling. If S, now here's the part I wanted to do. Okay, I wanted to deal with the constant a little bit, and I also wanted to deal with this part. If s is decreasing at a rate of 400 miles per hour, how do I represent that derivative? All right, ds dt, and what is it? All right, we got to talk about the decreasing part, and this is why I did this problem. It's negative 400. Now, some of you are going to have a problem with that because you're thinking, oh my gosh, we're traveling negative miles per hour. No, you're not traveling. You're traveling 400 miles per hour. The distance between the plane and the radar station is changing at a rate of 400 miles per hour. But the negative just lets you know that that distance between them is what? Getting smaller. That's all. And in physics, we do that, okay? We always think about, when we think about velocity in physics, you know, you got positive velocities and you got negative velocities. You think of it as a positive velocity as either moving forward or moving to the right. You think of a negative velocity as either moving backwards or moving to the left. You think a positive velocity vertically would be moving up, a negative velocity moving down. Well, in this problem, in context of this problem, we're thinking about the distance s as being negative as it moves towards the radar station. Because as it moves towards the radar station, that distance is what? Shrinking. So that's why its rate of change is negative. If it was moving away from the radar station, that distance would be what? Increasing, and that derivative would be what? Positive. So you got to keep track. Increasing, positive derivative. Decreasing, negative derivative. Everybody say it with me. Increasing, what kind of derivative? Decreasing, negative. And if you don't know, then you need to think about it. If you look at the problem, you say, how do I know? Well, is the distance or what the variable you're looking at, is it increasing or decreasing? If that variable you're looking at is increasing, its derivative is going to be positive. If that variable you're looking at is decreasing, then the derivative is going to be negative. It's really important. That's going to play a big part next week. Look at x. What's x doing? I know the plane's traveling at a certain speed, but is the derivative for x is dx dt, because that's what I'm after. The problem says, what is the speed of the plane? The speed of the plane is going to be the ground distance, how it's changing, so dx dt. So that's the one we're after. Is that distance changing at a negative rate or a positive rate?
Negative.
Why? Because it's shrinking. Doesn't mean that the plane's traveling slow. It's traveling fast. It's going really fast. It's going so fast, it's going to make this distance shrink faster. Okay? But what the negative just lets you know you're moving towards the radar station and this distance is shrinking. That's it. So we're after dx dt. That's the one we're after. Okay? So let's work on this. What's an equation that relates x and s?
X squared equals s squared.
Now, how does x squared equals s squared? What in what planet?
When it reaches x squared plus
X squared plus h squared. No, not 0. X squared plus h squared equals s squared. You with me? Now, do we want h? Am I interested in h? Do I want to know its rate of change? I don't care to know its rate of change. Now, here's a different rule for this one. I actually do know its rate of change. Its rate of change is what? 0. It's constant. So since it's constant, you plug the 6 in right now. You still gotta fit the Pythagorean theorem here. So, but I don't want it. I'm not interested in it. Now here's the deal. If you forget to do it, it won't matter anyways because you'll get a dx dt, and you know dx dt is 0, so it'll zero out anyways. But a lot of people don't remember that dx dt is 0, so I always say plug it in if it's not changing in the beginning. All right, can I do it now?
Yes.
All right, let's do it. We got everything we need, so let's go for it. 2x times dx dt, good, plus 0 equals,
whatever happened in
Two
just
s
setting like
times
s equals
ds.
s equals the square root.
you could do it, but I'm not going to this time. I'm just going to do it as is, and we'll do it later. Okay, 2s times what? And that probably didn't have to either. We could have left it z squared and then we did it later. All right, so we got 2x dx dt plus 0 equals 2s ds dt. All right, we've got a problem. Let's plug in what we know. Do we know x? Oh, wait a second. We don't know x. Okay, let me read the problem again because there's got to be something there. an airplane is flying on a flight path that will take it directly to the radar tracking station. If S is decreasing at a rate of 400 miles per hour, when S equals 10, there's our moment in time. So when S equals 10, H is always 6. I wonder what X is. I wonder if we can figure out what X is. Use Pythagorean theorem again. So we got X squared plus 6 squared equals 10 squared. This is different. We're using it for the purpose of trying to figure out when S is 10, I want to know what X is. So it'll be X squared plus 36 equals 100. We'll have X squared is equal to 64. What is that? 8. All right. So we got S equals 10 and X equals 8. That's the moment in time that I want to find dx dt. When I get to a position where X is equal to 8 and S is equal to 10. We're 10 miles directly away from the radar station and our ground distance is 8 miles away. So let's plug it in. So 2 times what? 8 dx dt is what I'm looking for. What? What? Did I spell something funny? All right, 2s. What's s? 10. What's ds dt? Now, if you don't have that negative, you're not going to get the answer right. Okay? All right, so we got this. Let's solve it. This is going to be negative 8,000, right? Divided by 16? What do you get?
You get 80. Negative 80. Is it 8,000
By 15. 16.
Oh, 16.
Negative 8,000 divided by 16. What do you get? Negative 500. What's the units? X is in what? It's ground distance, so it's miles per what? Now, why is it negative? That distance is decreasing. Very good. Now, one more I want to do real quick. This is like all your homework problems are going to be like this one. And you're just going to have to bear with me here. Okay? I'm going to try and get it done before the bell rings, but we'll see.
It's turkey gravy today.
I know. Suck it up. All right, here we go. Conical sand piles. Listen. Pretty much all your problems are like this today. Right here. They're like this. A sand and gravel plant. At a sand and gravel plant, sand is falling off a conveyor belt. So you have this conveyor belt, and sand's coming off the conveyor belt, and it's dropping, and it's forming a conical pile. Okay? That's my drawing. Get over it. So you got this conveyor belt. Sand is dumping off the conveyor belt. And remember, you take sand in your hand, you dump it. What does it form? A cone, right? A little Hershey kiss. Okay? So you got it? All right? So we know we've got a cone. Let me draw my cone here. I'm going to draw a pretty cone. I like cones. What's a cone? What are some of the things you know in a cone? Give me some of the dimensions.
Areas like 1/2 base times height, right?
That's an area of a triangle. Talk a cone here.
Areas like, is that 1/3?
Well, before you give me a formula, let's just give me some of the variables. What are some of the variables? Radius, what else?
Diameters.
Height. You got diameters, 2 radius. Volume. Does anybody know volume formula? A cylinder is pi r squared times h. Does anybody know a cone? How much of a cylinder? It's 1/3 pi r squared h. That's always given, by the way, on the AP exam.
Or is that going to be like on just a page?
It'll be given on that problem. It'll just say hint volume of the cylinder is this. All right, sand and gravel pit. Sand is falling off a conveyor onto a conical pile at a rate. All right, sand. How much sand is falling into the pile at a rate of 10 cubic feet per minute? What is that? dV dt. Let's write it down. dV dt is equal to 10 feet cubed per what? Minute. All right, let's go on. The diameter of the base of the cone is approximately 3 times the altitude. Now, this seems like it's so left field, but it's not. Let me just read it again. The diameter of the base of the cone. Diameter is just 2 radii, right? Radius is diameter. The diameter of the base is approximately 3 times the altitude. Altitude is just h. Now, it seems like that's not important right now, but it's going to be important because I bet you they're giving me that because there's a variable I don't want. And I told you they're always going to throw a bone. Here's your bone. This is going to help me get rid of something I don't need necessarily. So we'll get back to that. At what rate is the height of the pile changing?
So could you just solve for?
So what do I want? What am I looking for? What rate am I looking for?
Radius.
I'm looking for dH dt, but there's one more that's changing. There's also a dr dt, but did I give it to you?
That's not changing after.
It'll change.
Well,
It will, just keep changing.
Yeah,
As the pile gets higher,
15.
the radius is going to get smaller as the pile gets higher. So, I'm interested in this height. Does everybody understand I'm interested? Do I need DH? Am I looking for DHDT? That's the one I'm trying to find. Do I know DVDT?
Yeah.
Do I know DRDT?
No.
Do I want DRDT?
No.
I don't want DRDT. I don't like DRDT. We got to get rid of DRDT because the equation that relates it is this one. V equals 1/3 pi r squared h. It has something in there that I do not want. Now there was something that I gave you
So could you just solve for h on that equation? Plug that in there.
right up here, but I've got diameter is 3h. What is diameter really?
2 times.
Diameter is really 2 times the radius, right? So when I say the diameter is 3 times h, I'm really saying 2r is 3 times h. Which one do I not want? I don't want radius. So I can use this little bone they threw me and solve for what? Solve for radius. R is equal to 3h over 2. And then you put, hold on, I'll get you through this, hold on. 3h over 2, I won't hold you much longer. Squared times h, there's your equation. No r, just h's, just b's. It would look like this. It would simplify. This would be 9/4. So it would be 3/4 pi h cubed, and then you would do it implicitly and plug in what you know and get the answer.
You get h.
H squared times h is h cubed. This ends up being 9/4. 9/4 times 1/3 is 3/4. And then you just do it implicitly. Okay, I'll make another video on one of these problems. There you go. We got it good. Good jump on this. We're going to finish this up Monday, so